Just a few years ago, creating quality animation and visual effects cost tens of thousands of dollars in software and hardware costs. But free open source software has come a long way. In this video, we'll take you through Blender, a completely free and highly capable 3D animation package that has been used on major full-length animated features as well as live-action visual effects shots. A lot of work has been done to make Blender easier to learn for newcomers, so now is the perfect time to get to know its deep, powerful feature set. As usual, we'll get you up and going in under 30 minutes, starting now. To install Blender, head over to blender.org and download the latest version for Windows, Mac OS X, or Linux. We'll also be using a sample scene from Agent 327, one of the Blender Foundation's open source animated movies. Download the sample scene from the link provided in the description, then unzip it to your Documents folder. This is a customized version of the scene specifically for this tutorial. For more Blender sample projects, sign up for an account at cloud.blender.org. Once you've installed Blender, launch the application. Choose Edit, Preferences, then select Key Map. Choose Industry Compatible as the key config preset. Industry Compatible is another way of saying the standard Maya mouse and keyboard navigation. Why not stick with the Blender defaults? Well, most 3D content creation packages include Maya navigation shortcut sets, so learning to use Maya shortcuts with Blender will save you from having to constantly rewire your brain when switching between software packages, which you'll end up doing a lot. That and the fact that we'll be using the Maya navigation keys throughout this tutorial. We will make one quick change to the key mappings. At least with the initial Blender 2.8 release, there's no keyboard toggle between single and quad views in the viewport. Expand the screen section, click Add New, then expand the newly created binding. Type in all lowercase screen.region_quadview and press Enter. Now click the A button and press Spacebar to assign it. That's the toggle key in Maya, but because Blender already uses that to start and stop playback, we'll add the Shift modifier as well. Close Blender Preferences when you're done. Click in the viewport and press Shift Spacebar twice to test the toggle. Now, if you're completely new to 3D animation, you'll want to watch our quick primer, 3D Animation Fundamentals, for a solid understanding of the basic XYZ axes, navigation and transformation methods, as well as other terminology. Right out of the gate, Blender has added a simple cube to help you get your bearings. So that we have more interesting content to work with, choose File, Open, navigate to the scene file you unzipped earlier, and open blendersurvival.blend. The viewport defaults to a basic shaded view. If you have a reasonable graphics card, click the Look Dev Shade button to switch to a game engine like Preview. It may take several seconds or even minutes for Blender to load all the image textures into the scene. Once it's done, you should be able to manipulate the view easily. When working in 3D, you're usually either moving objects around in the scene or changing the position from which you're viewing the scene. Let's start with the latter, changing the viewing position. First, make sure you're in the Layout workspace. To rotate the scene, hold down the Alt or Option key and click and drag with the left mouse button. To zoom in and out, scroll the scroll wheel, or hold down the Alt or Option key and right-click and drag up and down. And to pan across the scene, hold down the Alt or Option key and middle mouse drag. The middle mouse button is the scroll wheel on most mice. Take a bit of time to get comfortable with these navigation shortcuts as they form the basis by which you do all your work in 3D. Now, if you get a little lost, select an item like a trash can or a car and press F to frame it at the center of the view. And just to clarify, you're not moving the object, you're changing the position from which you're viewing the object. It's like walking around, say, this car if it was in the real world. The car stays right where it is, it's you that's doing all the legwork. Okay, So now let's learn how you can actually change the position, scale, and rotation of an object in the scene. Left-click on one of the trash cans to select it, then press the W key to switch to the Move tool, or select it from the Tools list to the left side of the viewport. You'll see 3 arrows and 3 squares appear right at the center of the trash can. Drag a handle to move the trash can along an axis, X, Y, or Z. Drag a square to lock movement to a plane, either the XY ground plane or the XZ or YZ planes. Note from the gnomon at the top right of the viewport that Blender is a left-handed coordinate system, with X as the horizontal axis, Z being the vertical axis, and Y the depth axis. In the case of this scene, the road is lined up with the horizontal X-axis. Again, if you're unsure what the terms mean, watch our 3D animation fundamentals videos. Press E to access the Rotate tool, and R to access the Scale tool. Q returns to the standard Select tool. Unlike other applications, there's no center cube on the Scale widget for uniform scaling. Instead, click anywhere between the inner and outer ring without touching any of the axis or plane scale handles and drag. You can also enter precise mathematical values for translation, rotation, and scale in the Object tab of the Properties editor to the right. By the way, if you press Ctrl-Z or Command-Z to undo, you'll find Blender is quite slow to perform the undo once there's a bit going on in your scene. That's because Blender saves the entire scene file into memory for the undo buffer. This is possibly the Achilles heel of Blender. Just be patient. It will eventually happen. Usually. Don't go pounding Ctrl-Z or you may undo too much. The interface in Blender is fully customizable, but the Blender Foundation have worked hard to create an intuitive layout, so we advise you stick to it as you learn the ropes. Along the top of the interface are Workspace tabs for each major task you'll perform when creating 3D content. Laying out objects, lights, and cameras in a scene, modeling, sculpting, editing UV maps for texturing, and so on. One of the potentially confusing things about Blender is that the window layout saves with each project file. So if you load someone else's Blender project, the interface may end up looking completely alien. Don't panic. If this ever happens, or if you accidentally alter the interface and confuse yourself, you can delete the offending workspace, like the layout workspace here. Simply right-click its tab header and choose Delete. Then add back the default workspace by clicking the @ icon to the right of the tabs. You can then right-click the Workspace tab and choose to send it to the far left or far right, shuffling out other tabs in the same fashion. You may also need to change the shading mode again. Admittedly, this is a little clunky, but it'll get you back to a screen that looks like ours if you get a little lost. Okay, let's return to the Layout workspace and dig a little deeper into the interface. At top right is the Scene Outliner, a list of all the elements in your scene. To understand the outliner, it's worth quickly covering the structure of a Blender project file. A single Blender file can actually contain multiple scenes, with each scene sharing the project's objects, materials, and so on. You can add a new scene here. Either create a new scene with default settings, copy settings to create an empty scene with settings matching the current scene, create a linked copy to create a scene whose objects are shared with the current scene, or full copy to create a copy of the current scene with unique copies of scene objects that can be altered without affecting the objects in the original scene. We'll create a new scene by copying. You may notice there have been some changes to the scene. Blender has enabled scene elements we had hidden in the original scene. You can switch between scenes by clicking here. We don't actually need to fill up our hard drive with extra scene data, so let's click here to delete the new scene and return to the original. In the Blender project structure, all objects belong to the master .blend file. If you add them to a scene, a reference to the object is added to what's called the scene collection, basically a container for all the objects specifically being used in that scene. You'll notice that this scene already has several user-created collections used to organize the content. Here, we'll enable the smoke collection to unhide it, then click its disclosure triangle to expand it. It contains several animated smoke cards to create the illusion of smoke plumes coming from the chimneys. Click the disclosure triangle again to tuck them away. You can create your own collections to help organize a scene by clicking this button. For example, let's expand the foliage and trash collection. We have individual leaves, trees, and trash bags in this collection. Let's say we want to further organize them into 3 groups. We'll start with the leaves. The new collection will appear inside whichever collection you had selected when you clicked. So we'll select the foliage and trash collection header, then click the New Collection button. It gets added directly under the selected collection. We'll double-click to rename it. Now we want to drag all the leaf objects into the collection. In other applications, you would select the first item, then Shift-select the last item, selecting all between. Not so in Blender. Instead, with your mouse over the scene outliner, press the Q key. Now, click and drag through the items you want to select. When you're done, click on one of the items and drag over the top of our new Leaves collection, then release the mouse. We'll collapse the Leaves collection, press Q again, select more leaves, and add them to the collection. We'll repeat until all the leaves are safely tucked away in our new collection. Repeat to create collections for the trash and trees. It's important to note, if you're coming from other applications like Maya or Modo, that collections are only for organization. They have no transform and so don't act as parents. They're essentially organizational folders. To create a parenting relationship, you would add an empty, Blender speak for a null or locator. Once you add an empty, you can shift-drag objects onto the empty to parent them. Empties do have transforms and so can be used to move, rotate, and scale groups of objects together. A final core element in the outliner is the concept of view layers. Create a new view layer by clicking here. We'll call this new view layer Agent Solo. Now we'll turn off all the collections that are currently enabled and instead enable the 2 agent collections, which contain the geometry and the rigging for the main character in the scene, Agent 327. View layers allow you to quickly switch between different configurations of visible objects. We can now jump between the background scene in our original render layer view and the solar scene with only Agent 327 visible. Below the outliner is the Properties pane. There are several tabs for viewing and adjusting properties for different aspects of Blender. Settings for the currently active tool, the active renderer, output settings, multipass rendering, scene settings, including the renderable camera, and various object settings, starting with the object transform parameters. At the very base of the interface is the timeline. Let's enable the agent collection so we have some animation to look at. Click and drag the blue current frame indicator on the playhead to reposition it. Assuming your viewer is framed so that the barbershop is visible, as your playhead passes frame 150, you'll see the agent approach the barbershop and peer in the window. You can also play back the animation in real time by pressing the spacebar or using the transport controls at the center of the timeline. You can choose what Blender does if rendering the animation is slower than the scene frame rate. In the playback menu, choose No Sync to play every frame, ignoring audio sync. This is useful for simulation work. Frame dropping to skip frames if needed to maintain the scene frame rate, or AV sync, similar to frame dropping but focused on maintaining sync with the video sequence editor, Blender's native NLE system. We'll switch to No Sync so we can see every frame of animation regardless of system performance. You can see the actual achieved frame rate in red at the top left of the viewer. Let's quickly create our own animation. Click the Jump to Start button to rewind to frame 0. Now click the Record button to turn on auto keyframing. Select one of the trash cans and position it wherever you like. Notice the diamond that appears in the timeline indicating that the movement created a keyframe for the trash can at frame 0. Now move down the timeline to around frame 20 and move and rotate the trash can to look like it's been tossed down the street by some invisible cosmic force. If you like, you can manually enter some rotation values in the Properties panel to the right. Make sure the Object tab is the active one to see the transform values. Now that you have keyframes in the timeline, click the Next and Previous Keyframe buttons to jump between them. Switching to the Animation workspace, you can see a dope sheet with the keyframes loaded. Click and drag the summary keyframe at frame 20 to adjust the timing of the animation. To switch to a graph editor instead, click the Editor Type button and choose Animation Graph Editor. You can see that Blender has automatically applied an easing to the motion of the curves. Click the Editor button again and switch back to the dope sheet. We don't have time to dive too deep into keyframe editing right now. This is a survival guide after all. Let's switch back to the Layout workspace to continue our tour of the interface. It's time to tackle the all-important Viewport. We've already mapped our Shift spacebar so that we can toggle between quad views and single perspective. Let's take a look at some of the other key features here. One of the more unique workflow features in Blender is the concept of a 3D cursor. Select it at left or press C to switch to it. Now click on part of your scene. A small broken line circle appears. Notice if you rotate the view that the circle is actually located on the surface of the object you clicked on. The 3D cursor is used throughout Blender for various tool operations. For one clear example, choose Add, Mesh, Monkey. A disturbing large monkey head appears centered on the 3D cursor position. Select the monkey head and press Delete. If you want a new object to be added at the scene origin instead, first right-click the viewport and choose Snap, Cursor to World Origin, then add the object. In this scene, the origin is located at the edge of the barbershop. Press Q to return to the standard Select tool. To reduce clutter, Control left bracket will hide or show the toolbar. Control right bracket will show or hide a handy sidebar with access to the most common properties you'll want to adjust. At top left of the viewport is the Object Modes menu, allowing you to choose between different edit modes. Right now, if you click the Modes menu, you'll see just the one mode. That's because the items in this scene are referenced from an external scene file, and Blender is preventing you from making changes to objects that might affect how those objects appear in other scenes. Instead, select the scene collection, then choose Add, Mesh, Torus, and a torus is added to the scene. By selecting the scene collection, we ensure a new object gets added to the top level of the scene. Now the other modes will become available to you. Select Edit Mode. Drag select some of the faces and choose Mesh, Extrude, Extrude Face along normal. Now move the mouse up and down to adjust the extrude amount. Left-click to complete the extrusion. To switch between selecting vertices, edges, and faces, click these three buttons or use the keyboard shortcuts 1, 2, and 3 respectively. Double-click to select a loop, and Control-click the vertex, edge, and face buttons to convert the selection to a different type. Unfortunately, we don't have time in this guide to delve any deeper into the modeling toolset. Returning to the Modes menu, you'll see there are additional modes for sculpting and painting. Switch back to the object mode, and you can now manipulate the object in the scene without affecting its shape. Rounding out the viewport, we have shortcut menus to view configuration, selection methods, object creation, and editing. Then controls for selecting the transformation axes, the pivot point for transformation operations, geometry snapping enable and options, fall-off options, master viewport object type visibility, on-screen control and overlay visibility toggles, X-ray mode toggle, and viewport shading modes, which we met earlier in our guided tour. We'll take a look at the last shading option in just a moment. Below this are toggles between perspective and orthographic projection, toggle to and from the current scene camera view, alternate view pan and zoom controls, and the 3D view gnomon. You can actually use this to switch between various orthographic views by clicking the appropriate axis label. Before we wrap things up by adding lights and camera, we'll add a material to our now misshapen torus. Select it and choose Object, Shade Smooth to produce a more curved shading effect. Now we'll jump to the Material tab in the Properties pane and click New to create a new material. We'll give it a name, choose a color, and play with a few of the values. Right now, the viewport is only giving us a rough approximation of the final look. Click here to enable the final production renderer, by default Blender's Cycles render engine. It may take a long time to cache all the textures for the scene, so be patient. Since we want to focus on adjusting the torus's material, select it and press Shift-H to hide everything else in the scene. Once that's done, the renderer will be much more responsive. Now, if you have a fast graphics card with a decent amount of video RAM, in the preferences you can select CUDA for NVIDIA cards or OpenCL for AMD cards, then make sure GPU Compute is selected in the Render tab. Back in the Materials tab, we can adjust the material properties and get near instant feedback as to the final look. You've probably noticed that the torus still looks a bit blocky. That's because its polygons aren't subdivided enough to look truly smooth. First, we need to enable subdivision rendering in Cycles. In the Render tab, choose Feature Set, Experimental. In the Object Modifiers tab, add a subdivision surface modifier and enable Adaptive. Don't apply the modifier. That makes the subdivision a permanent part of the geometry, something you almost never want to do. When you're happy, press Alt-H to unhide the rest of the scene. Now, the torus has served its purpose for us. Unless you've created a masterpiece, select it and press Delete. Time for lights and camera. For better interactivity as we set up, let's switch back to the Look Dev shading mode. So that this scene's built-in global illumination doesn't overpower our light as we preview it, click the shading options and make sure Scene Lights is enabled, but Scene World is disabled. Select the scene collection, then choose Add, Light, Spot. Use the W and E keyboard shortcuts to position and rotate your new light. Select the Lighting tab and increase the power to 1000 so that we can easily see the effect. Even though we created a spotlight, we can easily convert it to an area, sun, or point light. Feel free to experiment with the various light parameters. Now, this sample scene has a camera move already implemented, but we'll create our own camera from scratch. Select the scene collection, then choose Add Camera. Double-click it in the outliner to rename it, and switch to the Scene tab in the Properties Inspector. Select your new camera from the list. To have your camera match the current orientation of your viewport, choose View, Align View, Align Active Camera to View. Finally, press Ctrl right bracket to access the viewport sidebar. Switch to the View tab and enable Lock Camera to View. Now as you reposition the viewport, you'll be reframing the camera as well. Click here to toggle between the standard perspective view and your camera view. In the camera view, the grayed out portion of the viewport represents portions of the scene outside of the final renderable region of the camera. Make sure your camera is selected in the outliner and select the Camera tab in the Properties pane. You can lock the pane so that it's visible even if the camera becomes deselected by clicking this pin icon. Here we can change properties like focal length. To experiment with the depth of field preview, set the aperture to something wide like 1.4. Now click the eyedropper next to Focus Object and click on an item in the scene you want in focus. Click the X to remove the focus object and select another. And finally, time to render. In the Render tab, make sure the Cycles Renderer is selected. In the Output tab, you'll set the resolution and frame range, and then choose a render location. And we'll give our image sequence a name. As a final check, visit the Scene tab and make sure your camera is selected as the renderable camera. There are all kinds of optimizations we can make to the renderer, but we'll ignore those for simplicity and go with the defaults, except for sampling, which we'll set to a more humble 20 for our initial tests. Choose Render, Render Animation. If need be, you can cancel the render by pressing the Escape key. Remember, this is a fairly complex scene, so anticipate a long render time. Once the render is complete, you can review it by choosing Render, View Animation. And that's it for our Blender Survival Guide. Of course, Blender goes much deeper with dedicated physics simulations, paint systems, node-based compositing, camera tracking. The list goes on, but you now know enough to start working with Blender scenes and creating your own animations and imagery. Most importantly, when someone asks you, will it blend, you can confidently say, yes. Yes, it will.